Chapter 4, Chemical Quantities and Aqueous Reactions. Well, I'm sure that you've heard of global warming, right? And there's a lot of concern about what the heck are we doing to our planet. Helpful to understand the greenhouse effect. And I know this is not technically chemistry, but it's kind of interesting. So I'm not going to test you on the greenhouse effect. But what the greenhouse effect is that there are gases in the atmosphere that allow sunlight to penetrate and warm the earth, but then prevent some of this energy from leaving. If we had no layer of gas around our planet, the sun would hit the planet, warm it, and that heat would just dissipate into space. And our planet would be very, very cold and couldn't sustain life. So that presence of gases is necessary. Now, if you get too many gases, you get too much carbon dioxide in the air, then the planet would get warmer. If you have too little, it gets colder. So it's that balance between the incoming and outgoing energy from the sun that determines the Earth's average temperature. And that balance is influenced by the concentration of the greenhouse gases. Now, we tend to hear about, we're generating too much carbon dioxide, and so the planet's warming up, and this is all scary. Well, it's interesting if you read about it. We also don't want too little carbon dioxide in the air, because in the past, that's what's led to ice ages. You get a cold spell, and the ground gets covered with ice and snow in the northern parts of the planet, and then summer comes, but it doesn't completely melt away. The white snow does not absorb as much of the sun's energy as brown earth or green plants do, and so it doesn't warm up quite as much. And you can quickly go into this cycle where every year it gets colder and colder till pretty soon the planet's covered in ice, or parts of the planet are covered in ice. And so they've got evidence. I'm not a geologist or anything like that, but they have evidence that, this has happened in these big, long cycles. Question?
The cold spell, is it just random, or do they know something caused it?
I don't think they know what caused those initial cold spells, partly because those things happened before recorded history. And so the evidence is, they're digging through layers of ice and they're trying to deduce what happened. And so they don't really know. But we do see, in our lifetime, we see that, oh man, that was a really hot summer, that was a wet winter. We do see these variations in climate. And so you can kind of see how if you had a couple of cold winters in a row, that could spiral into an ice age. So you don't want that happening either. So scientists have measured average atmospheric temperatures since 1860. Now let's think about this. How do you measure the average temperature of the planet? Is that a super precise number? No, because how many places are you sampling on the planet? Are you looking at one location? Are you looking at 5,000 places? What elevation? So just the question of what is the average temperature of the planet this year, there's a fair amount of uncertainty in that number. So they've measured, They found an average of a 0.7 degrees Celsius temperature change since 1860. Now, 0.7 degrees, that's not a lot. When you look at it over here, so here's 0. They're saying, well, this is a baseline temperature deviation. So 0, here it was below, and here it's above. This graph can look alarming, right? It's, oh, it's going up, but it's really dramatic. Well, the smaller you make this temperature scale here, each block is 0.1 degrees Celsius. If you make that 5 degrees Celsius, it looks like a straight line. So we're zooming in on it, and you can, this is an example of how you can make data scary or not scary, right? And that's why I think it's helpful for people to take some science classes so that you have a clue when you see these things in the newspaper. Because a lot of times they're trying to scare you because they have some agenda that, you know, they want you to be afraid of, so you'll buy their, you know, car with low emissions or something. So here's the data, and we do see this trend. There's definitely a trend here. But look at the individual ups and downs. Is that difference really that much more than these individual ups and downs? Well, that's something that, you know, people can argue about. So yeah, the temperature's gone up a little bit. We should be concerned. Do we need to freak out? No, we don't need to freak out. Well, they've also measured carbon dioxide levels. These are parts per million since 1860. And again, where are they measuring this and how accurate? You know, those are questions that you should have. I'm not saying that this is not valid science, but I'm just saying we need to just not take something that someone presents to us at face value. That's not what scientists do. We say, well, how did you do that? Where did you measure it? What's the, you know, error in your measurements, et cetera? So here we see it going from 200, below 290 to above, a little above 390. So the atmospheric CO2 levels have risen 38%. So we see a rise in CO2 levels. We see a rise in temperature. Does that mean the carbon dioxide levels are causing the temperature to go up? Or is the temperature causing the CO2 levels to go up? That's called a causal relationship, where one thing causes the other. Are the two trends causal, or is it a coincidence? Well, because we're looking at the whole planet, it's not like we can do an experiment. What I like about chemistry is you can control things. You can set up something in the lab, and you can do an experiment. You can't do an experiment on the planet very easily. We're kind of doing one by trying to lower the carbon dioxide levels. But that's a really long-term experiment. Anyway. Well, where's this carbon dioxide coming from? Well, obviously, one source is from the combustion reactions of fossil fuels. And we just looked at balancing those sorts of reactions. So this is octane, which is often used as a representative compound for like gasoline and other fuels like that. It combines with oxygen in the air as it burns, and it produces carbon dioxide and water. So definitely, you know, most of us got to school this morning by motor vehicle. They probably used gasoline. So we put more carbon dioxide into the atmosphere. But there are other sources of carbon dioxide. One of them is volcanoes. Volcanoes are spewing carbon dioxide into the air too. So, is global warming natural, perhaps from the volcanoes, or is it due to our use of fossil fuels? Well, we can actually do some estimating and get an idea of which is more important, the volcanoes spewing CO2 or us burning petroleum products.